All right, so next slide, please. So I think the slide shows. All right, there we go. Okay, so hi everyone. My name is Charles, and I'm going to be your VP Technical Writing for this year. And so this is an event that I've been looking forward to for quite some time, as I'm sure many of you have been as well. Because like for the past couple months, I've gotten quite a few questions from people about like, what machine learning is and what do you need to know about it and how much do you need to know to be a project developer? So for those of you who have specific questions, I ask that you stick around to the end. And so for like the Q&A and the interviews with the project directors, as for the rest of you, my goal here today is to give you some knowledge and resources to get started with machine learning. So next slide. Okay, so first of all, what is machine learning? You might have heard the term tossed around with other terms like artificial intelligence and deep learning, but they actually don't all mean the same thing. So machine learning is a subset of general AI, and deep learning in turn is a subset of machine learning. So artificial intelligence is essentially the imitation of human intelligence by computer algorithms for the purpose of accomplishing specific tasks. Machine learning is more specific in that data is used to teach specific algorithms to perform specific tasks. So certain types of AI, like for example, some in video games, often do not require data, which is what differentiates them from from machine learning algorithms. And so the two main categories of machine learning tasks are supervised learning and unsupervised learning. There's also reinforcement learning, but for the sake of keeping it brief today, we won't be diving into that. Next slide, please. So supervised learning encompasses algorithms that learn from what's called labeled data. So think of it like giving the algorithm a set of test questions and then telling it the correct answers at the end so it knows how well it did. And so the two main categories that fall under this task are regression and classification. Now, some of you might have heard of this if you've taken like a basic intro to stats course. But however, perhaps more importantly, deep learning also falls under this category. And we'll be talking about this a little bit later. So as you'll soon find out in your machine learning careers, obtaining high quality labeled data to train machine learning models is a big challenge in and of itself. Next slide. So I made the analogy of teaching the algorithm to learn by essentially giving it data. But how exactly does it do that? Well, this is basically one of the most important concepts. And so let's cover it. Supervised learning algorithms use something called gradient descent, which is an iterative optimization algorithm used in conjunction with a loss function to improve a model's performance. If that sounds confusing, just think of it like the loss function being like a grade, but instead of a higher loss being good, it's actually bad, and you want a lower loss. And so in order for the model to achieve a lower loss over time, it does this by changing what's called its weights. Which is kind of like its memory. And so the more the model trains, the more it updates its weights through feedback given by the loss function by comparing its predictions to the actual correct answers, hence the importance of labeled data. As the loss continues to lower, the weights become more and more optimized until the model finally learns to do a task. Next slide. So for those of you who want a more mathematically visual representation, this is what gradient descent basically looks like. So essentially, the goal of the model is to have its loss, represented by J here in the y-axis, to be as small as possible by updating its weights W in the x-axis. So as you can see, the loss essentially decreases following a gradient, hence the term gradient descent. And for those of you who haven't taken basic multivariate calculus, don't worry about it too much, but the gradient essentially is just the derivative. And so once the loss gets to a low enough point, we can stop the model training and actually deploy it in an actual setting. Next slide. So the second category of machine learning algorithms is unsupervised learning. For unsupervised learning, the data is unlabeled, meaning the algorithm is given no right answers to compare its work to, essentially. Rather, the algorithm is just given a set of data and told, all right, good luck, figure it out. reminds me of the way that some of my courses were taught. But anyways, so for unsupervised learning, the three main subcategories are clustering, non-clustering, and classification. So clustering involves, well, finding clusters that group data together to extract meaningful patterns. And so if you want a good example of this, feel free to check out the employee attrition factors project from last year, where basically they figured out different factors and they grouped them together using clustering to determine what factors were key causes for employees essentially leaving their jobs. And so non-clustering algorithms actually change the input data as opposed to clustering algorithms which don't. So some of you may have heard of PCA, or principal component analysis. And this is a common method for reducing what's known as the dimensionality of complex data. It is often used in conjunction with, say, neural networks or other machine learning algorithms in order to increase speed or performance by lowering the complexity of the input data. And so last but not least, though it is less common, there's also unsupervised classification used for tasks like anomaly detection. Next slide. Okay, so now for the good stuff. Deep learning, as I mentioned before, is a subset of machine learning, or more specifically, supervised learning, because it still uses labeled data for training. The difference between deep learning and supervised learning is that deep learning leverages the power of neural networks to perform more complex tasks than a simple model like a regressor can. So as you can see, rather than the entire model having one set of weights that's trained all at once, each neural network has individual nodes, which have their own set of weights. And so each node is trained in a process called backpropagation. And so for the sake of time, I won't delve too much into this, but essentially gradient descent works the same way for each node. And it propagates from the last node. I don't think you can see my cursor, but the output layer, which is like the last nodes, right? Where it essentially compares its prediction with the actual answer given by the labeled data. And then it does this, and the weights of each of the nodes is updated backwards through the hidden layers until it reaches the input layer. And so essentially it propagates backwards through the neural network, hence why it's called backpropagation. And so by having each node possess its own set of weights, the entire neural network is capable of much more complex functions, similar to how your brain is capable of more complex functions because of the interconnected neurons. Next slide. And so, of course, in machine learning, there's no one model fits all. Depending on the task at hand, the neural network architecture required can be dramatically different in relation to its size, the type of layers it has, the way those layers are interconnected. And so each architecture has its own pros and cons. To give a simple example, for example, right, larger models require more data and more training time to be effective. However, smaller models are more prone to overfitting, which is basically like memorizing the results based on the training data, which is not what you want. You want it to learn. And so there are probably tens of thousands of models proposed in papers for specific use cases, but the most famous ones are often the most versatile or the most fundamental architectures. And so we'll be talking about that right now. Next slide. So neural networks and machine learning are fun and all, but by themselves, they don't really seem like the society-changing paradigms that most people make them out to be. Well, that's where the other subfields of AI come in. One of the largest of which is known as computer vision, which deals with teaching computers to interpret and understand visual data. This subfield is often used in conjunction with neural networks and deep learning, more specifically by leveraging the power of convolutional neural networks in order to perform useful tasks. So CNNs are one of the fundamental neural network architectures that I mentioned before. And so all of this is what powers technologies such as visual sensors on robots, smart medical imaging and diagnostic technologies, self-driving cars, and those creepy sci-fi surveillance technologies that you see in movies. Next slide. So I talked about useful tasks, but what are some examples of this? So if you don't understand all of these terms right now, don't worry too much. But you'll come across like many of those if you decide to work on projects related to computer vision. So some of the famous ones, for those of you who have a little bit of prior learning knowledge, might seem familiar, like for example, classification. If you do decide to do a computer vision project or learn computer vision, one of your first projects will probably be a simple classifier. For example, determining whether an image has a cat or a dog, right? And another famous task is known as object detection. And so basically, this is used in a lot of applications, like, for example, the self-driving cars that I mentioned before, basically finding objects of interest within an image. So you can see there on the right, there's actually a picture describing what object detection is. And so you can imagine in a self-driving car scenario, it should be able to detect things like pedestrians, other cars, perhaps even like ice on the road, stop signs, traffic lights, things like that. And last but not least, something for you guys to maybe look into yourselves is image synthesis. So you might have heard of like diffusion models such as DALL-E 2 making a lot of headlines these days for their capability of basically taking a string of text and then translating that into an actual piece of art. So lots of interesting stuff going on. Next slide. And so another famous subfield is known as natural language processing, or NLP. So NLP involves teaching computers to understand text and spoken words, otherwise known as language. So NLP is used everywhere, from Grammarly to Google Translate to GitHub Copilot to the autofill on the search bars and all the way to sentient robots or sentient chatbots. The most famous of these models is undoubtedly the transformer, originally proposed in the paper "Attention is All You Need." Now, I would not recommend this as a first read because it is a fairly difficult and long paper built on a lot of past work. But I'm only bringing this up because the largest neural networks in the world are built on essentially the transformer architecture. And the reason for this is because larger language models, or why the transformer is important, is because larger language models can learn from a lot more data. And so this allows them to do extraordinary tasks like write essays, generate code, translate messages across numerous languages, and even trick people into thinking they're alive. Next slide. However, the reality is that most NLP tasks are a lot less dramatic, albeit still very useful. These are just some of the tasks listed that large language models like GPT-3 are capable of doing. The difference is these large language models can usually do most, if not all, of these tasks to a large degree of effectiveness or efficacy, as opposed to computer vision models, which usually are only able to do one or two tasks at a time. And so that's the power of large language models, the transformer architecture, and natural language processing. Next slide. So you might be wondering, okay, so all of this sounds pretty cool, but it's a bit overwhelming. Where do I get started? I don't have the stats and linear algebra knowledge needed. You might be in your going into your first or second year of university and might not have taken all the required courses to understand the theory behind a lot of this. And so what do? Well, first of all, there are numerous free resources online to teach you these things. And so these include YouTube videos, Medium articles, and a lot of these help you essentially get started creating some of these projects in machine learning on your own using frameworks such as TensorFlow, PyTorch, and scikit-learn. And so as you slowly immerse yourself in the world of machine learning, all these technical terms and jargon that I mentioned before will slowly become less and less intimidating. And the best way to start immersing yourself right now is to join UTMIST. And so we have a variety of different opportunities across different departments. As I'm sure most of you know, we already have the project developers, which allows you to basically work on a machine learning project with a bunch of other developers led by an experienced project director. And some of the other initiatives that we have include the project workshops, which are monthly sessions where attendees can complete beginner-friendly applied machine learning projects. And then there's also the paper reading group, which dissects difficult papers, including the Transformers one that I mentioned before, as a group. And the study group gives you the opportunity to essentially do a Coursera course sponsored by UofT. And a lot of these courses are often blocked behind paywalls, but we're giving you one for free. And so needless to say, all of these opportunities are still available. And for those of you who are interested into delving into machine learning as complete beginners. And so with that, I'll hand it off to Ariel, who will be discussing more about what to expect if you apply as a project developer.
All right, thank you, Charles. That was a great session on Intro to Machine Learning. Yeah, and hi everyone, I'm the VP Academics this year, and Stephen and I will go through some of the projects this year and the recruitment. So yeah, let's start with the projects. We have many great projects this year, ranging from finance, game development, to research that will be aiming for publications. And the directors will discuss more details about those projects later. And among the projects, 3 of them are new this year, and then, 4 of them are new this year, and then 3 of them are from last year. And we're also collaborating with startups, so the details about those projects will come later this month. Yeah, next slide, please. So yeah, we currently have 4 opening positions. Of course, the project developer for the 7 projects I mentioned on the last slide. And we're also hiring both project directors and developers for the 2 startup projects, which will be the Omni AutoML and PhotoML. But once again, the details will come later this month. And we're also doing product associate and front-end developers. Stephen will be talking more about these 2 roles. Yeah, next slide, please. So yeah, I will be going through some of the general expectations of the 4 roles. So first thing first, commitment is very important. Whenever working in groups, it's really important to meet the due days. And I do encourage you to plan things out ahead of time, because we understand that things may pile up when school starts and everyone just gets busier and busier. And the second thing is communication, because communication is always the key. Try to be responsive, check your Discord and emails daily or regularly, and then be punctual for meetings, just show up in the meetings. And this style of efficient communication probably will just save everyone time. Yeah, and then when it comes to the internal communications, please do remember to update each other on the progress, update your teammates and directors, because keeping everyone on the same page would avoid a lot of confusion. Yeah, and also if you have any questions, or if you're feeling your task is too challenging or your workload is too heavy, you can always reach out to your directors for any coordination. And if you just have any problems or concerns in general, you can always ask on the Discord channel. I'm pretty sure the VPs and the advisors will always be there to answer your question, because we're all here to support you for your project success. And then last but not least, the most important thing for you is to learn and gain machine learning experience at UofT-MIST. So do keep a learning mindset. I know we all start from somewhere, and we all kind of need to learn along the way sometimes. So here are some of my personal tips for you if you are feeling you're stuck. When in doubt, you can always just Google, but do be careful when you are trying to find resources, because reliable resources will just start you off better sometimes. Some examples would be Google Scholar and UofT libraries. I'm pretty sure there are a lot of great free resources in UofT libraries. You can find any paper you want or textbooks. And also, if you have any question, you can always just ask in our Discord channel. The upper years, directors, VPs, advisors, we are all there to help. Yeah, next slide, please. So for the project developer role, a short description I would say is that project developers, they're the cool guys working on coding stuff, working on their topic of choice in a 6-month development cycle. And then the developers, you need to coordinate with the directors to build and test the models. And eventually you guys will contribute to the annual project showcase. And here, yeah, at UTMIST, you will meet many like-minded people and gain hands-on machine learning experience with potential collaboration with startups or research publications, as we have mentioned. So here are some qualifications for the project developers that we're looking for. The first thing and most important thing is you have to be passionate about machine learning. We're all here to learn, so your passion about machine learning is quite important to us. And even if you're starting with limited knowledge of machine learning, as long as you have the will to learn and as long as you have the motivation, we believe you will become a great developer. And we would also love to see everyone to grow throughout the year, and we do hope you can have great experiences with UTMIST this year. However, we do require that project developers have a basic knowledge in coding and previous experience with machine learning projects or usage of frameworks such as TensorFlow or PyTorch would be a bonus. And also, of course, the machine learning knowledge requirements will vary from basic to proficiency in project-specific domain. So yeah, just do pay attention when later on our directors are introducing their projects. And also, this year we have so many great projects ranging from different areas, such as ECG, which is the bio area, and finance or music or game development. So there is also project-specific knowledge and technical skills that are required by the director. Yeah, once again, keep an eye on that when the directors are introducing their projects later. With that, I will pass it to Stephen to talk about the other two roles.
All right. So I'm Stephen. It's really nice to see you guys here. I'm this year's VP of Engineering. And I really look forward to seeing you guys joining the team. But let me talk about the 3 new positions we have on top of developers this year. And first and foremost is the recruitment for directors and developers for our startup collaboration projects. It's one of our new initiatives this year. And the 3 startups we're working on with is AltaML, AutoML, and Omni Labs. So as directors, you will be leading the project in the coming year, which includes not only solving the technical issues, but also coming up with a plan to solve the entire problem that the startup has presented to you. During the process, you'll receive guidances from me and co-presidents of UTMIST. But this also means that there's going to be a much stricter role for qualifications, which includes a strong academic record and also exceptional project management experiences in machine learning. Also, we are expecting you to have the ability to create, plan, and execute the development of a minimum viable product in a 6-month development cycle. Of course, we also want you to have excellent communication skills to bridge the client-side requests with the technical developers and also just simply the technical feasibility side of things. And for the developers, the qualifications are similar to those mentioned just now in the previous slide, just with one small addition, which is that since you're collaborating with startups and trying to actually deploy a product, we do want you to be aware of the gap between client-side requests and again, the technical feasibilities or difficulties that might be occurring during the process. The second new role for this year is the product associate role. This is more of an experimental position this year, and you will be the representative for our project management advisors, such as StoryJ from AltaML. Your main responsibility this year is to work with 3 to 4 teams on product outreach. And that means this may include consumer outreach, consumer discovery, or perhaps even searching for competitions or investors to pitch the project ideas to them. So you'll work closely with the projects that you're the most interested in, and perhaps in the fall term or in the winter term. Since this is more of an experimentation role, you will have a great liberty in the approaches that you want to solve the issue of product outreach. So really looking forward to how this would go on. And the qualifications to this is to have experience with product management. We also want you to have experience with planning, creating, and perhaps even pitching a product to someone, and that would be a great bonus. Another bonus would be perhaps some of us here already have startup experiences, and if that is one of the experiences that you have, then that would be an excellent bonus to have. And the third role is a new team of front-end developers. Because in the past few years, all the projects are responsible with the websites themselves. And we're hoping to reduce the burden of each of the directors and developers when it comes to product outreach. So this year, we are trying to build a team of front-end developers, and there's 3 main responsibilities over the upcoming year. In the fall term, there's going to be 2 tasks. The first task is to build a website for our new MLH hackathon. And the second task will be to build a website template for our projects, which then you'll be using it for the winter term, where you will be responsible for working with specific projects to really connect their backend, the ML models, and to see how you could host a model on perhaps a demo page on the template website. The qualifications for this is that the ideal candidate should have experience with HTML, CSS, JavaScript, and also the relevant front-end frameworks. Proficiency in Python is a great bonus since that will allow you to understand the backend models in a much greater detail. And of course, we also want excellent communication skills since you will be working closely with the project directors and all the other front-end developers for some amazing projects this year. And regarding the recruitment period, it will start tonight at 7 p.m. All the information of the projects and the Google form for application will be uploaded to our website by 7 p.m. tonight. And it will go on for roughly 3 weeks until the 20th of September. There are 3 things to prepare for the application. First thing is you will have to fill in the Google form on the Join Us tab in our website. In the form, you will choose the position you're hoping to apply for. Feel free to apply for multiple positions. You just simply have to submit the application for multiple times. And in the Google form, you'll have to choose your position, choose the projects that you're hoping to join, and also you're required to fill in a short prompt in regards to why you want to join certain projects. At the end of the form, you will be required to submit your resume. And on a rolling basis, the applicants we accept will be invited to an interview by either from UTMIST directly or the project directors themselves. The interview will likely consist of 2 parts: the general interview, where we ask about your ML experiences, perhaps some soft skills when it comes to developing a project, and also the technical interview, where we will test out some of your ML knowledges. Once you get accepted, you will get an onboarding in the final week of September by the project directors. And hopefully as soon as possible, we would be able to start the development process in early October. And this will go on until March 2023. And the final objective, of course, is to present your ideas, your results at the end of the year at our annual project showcase, which will likely be held in May of next year. And now I would like to invite the project directors to actually share a little bit more about each of their projects, their recruitment infos, their project infos. And to start off that, I would like to invite Elliot and Walter, which will be sharing with you a little bit more about the project DiffMuse.
Hi, everyone. Can you all hear me? Hello?
Hello. Your volume is a little bit low.
Hello? Is this better?
Oh, much better.
Okay, great. Hi, everyone. I'm Walter, one of the project directors for DiffMuse. Unfortunately, Elliot is absent today. He's in Spain, but I will be, I guess, presenting on behalf of Elliot. So DiffMuse is a project on music synthesis, and we will be using a new type of model called a diffusion model. So essentially what we will be doing is taking a symbolic representation of music and either generating from a beginning part or filling in the gaps between 2 parts of filled in music. So for example, the image right there, the beginning and end was provided, and the red box was would be generated by DiffMuse. This figure is from one of the papers on the bottom, if you guys are interested. Our project attempts to combine a new type of sequencing model and called S4 and a generative model called a diffusion model, which is also the architecture behind Google's ImageN. The results from that model are very interesting. Essentially, you get incredible images from just a text prompt, and we are trying to leverage that to our own model with a symbolic music. And what we'll be doing is, if you've heard of MIDI, essentially we'll be taking a data like MIDI with additional information such as time signature, instruments, chords, and other stuff. And it will output a completed piece in that same format. And hopefully we will implement a web interface in which raw audio can be played from that format. If you want to see more information on the models being used and other stuff. Our proposal is linked in that slide. And yeah, we hope you'll be interested. Next slide, please. So as for recruitment, we're looking for 2 more developers and importantly, friends to complete our team of 6. What we need in our developers is the willingness to learn and work with new models. We're working with new types of models, and they also require a relatively deep machine learning background and mathematical background to understand the papers. We also would like experience with deep generative models and just general deep learning experience. And since we aim to publish or hopefully make publishable our findings, experience with research and writing a report would absolutely help. And some bonuses would be if you had some familiarity with music theory, MIDI formats, stuff like that. And even if you have an internship, that would be amazing. Anything helps. And experience with S4 or sequencing models and diffusion models. And yeah, we hope you'll like it and apply.
Amazing. Thank you, Walter. Thank you, Walter. And the second team is the Numer AI team. So let's have Andrew and Jency to talk a little bit more about them.
So hello, everyone. Can you hear me? Okay, fantastic. My name is Andrew, and I'm one of the co-directors of the NumRI Quant team. So our project essentially is to attempt to beat the leaderboards of the NumRI weekly tournament. So I'll go into more on that in the later slides. Okay, so first of all, what is it? So NumRI is a data science tournament hosted by the world's first crowdsourced hedge fund. So how does it actually work? So the hedge fund in San Francisco, they pay those data collection agencies to collect high quality financial data on the financial market, which are published in weekly rounds in the tournament. But these financial data are obfuscated, so which means that what each feature represents are hashed. So we don't actually know what each feature represents. So that's understandable because they paid a lot of money for those data to be collected. They don't want their competitors to get a hold of those data. So what our goal is to perform regression on the published data in weekly rounds and submit our predictions weekly as a CSV file to the hedge fund. So essentially, we're working for the world's first crowdsourced hedge fund. So if you're looking for a career as a quant or in the finance sector, I guess this project is really the project for you. And so why are we doing this? Most of all, why is the hedge fund doing this? Well, the hedge fund's AI, which is called the meta model, takes every participant's predictions as input and helps the hedge fund to make investment decisions. So if our predictions actually help the hedge fund to make money, we get in turn potentially rewarded with cryptocurrency, which is a cryptocurrency that they created based on the Ethereum blockchain. Once you join our team, we'll go more into detail on how that's doable. So next slide.
So our approach is to mirror the hedge fund's approach, which is a meta model on top of all the models that our team developers build. So we will ask our developers to build submodels whose output correlates with the actual output. So in the NumRI website, there's a diagnostic tool where you could plug in your output, and they'll tell you how good your model is. And based on that, we'll build a meta model on top of the submodels to ensure that it takes advantage of each submodel. And this makes our project horizontally scalable and accommodates for a wide range of technical abilities. If you're new to machine learning, it's okay for you to build a weak model, since every model would make a contribution to our meta model. If you're really skilled in machine learning, then your submodel will greatly contribute to our meta model. And each developer will build their own unique model on the data set and refine it so that it's good enough to be incorporated to our meta model. This makes our project different from the other projects since we give our developers freedom to choose whichever model they're interested in, and they could explore any model they want. And one thing we want to ensure is that our submodel needs to be diverse so that they can generate different outputs that correlates with the actual data. And with different models, our meta model would perform better as it could combine the pros of each submodels. And for the project, we want our developers to be proficient in Python, since all mainstream machine learning frameworks are based upon Python. And we want our developers to have a robust understanding of the basic machine learning concepts, which ensures that our member could build models that are more correlated to the actual data. And we want our developers to be eager to independently learn new concepts. Since, as I mentioned before, much freedom is given to our developers, and they need to be able to learn from, they need to be able to research the models they're interested in and implement it so that it could take inputs, take the given input and produce an output. And we want our developers to be able to commit 2 to 4 hours per week, since developing a good model takes time. And we want our submodels to be as good as possible so that our meta model could be fed with better input. And that's it. We hope that you could be interested to our project and apply for our project. Yeah.
All right. Thank you, Jancy. Thank you, Andrew. It's amazing. I think this project is really interesting because it's really horizontal. So anyone that has a decent amount of ML knowledge, feel free to join. If you're really good, maybe you could come up with something really novel. If you're new to ML, also highly encourage you to join. And it's just a good chance for you to try out different architectures during the entire process. But yeah, let's move on to the third project, which is called Virtual Creatures by the director, Andrew Magnuson. Unfortunately, he will not be able to speak for us today. I believe he is in the meeting, so if you guys have any questions regarding this specific project, you can just ping him or ping me. So I'll share the details of the project for him. But basically, this project is to reimagine the 1994 paper written by Carl Sims on evolving 3D virtual creatures. And if you look at the images on the right, that's pretty much the things that we'll be working on with. So basically, there's going to be a swimming environment, and you will be trying to create a creature that automatically evolves their topology and their neural network, which is going to be managing how it's interacting with the environment. So it's a super interactive project, and it really intrigues me personally. But basically, in the coming year, there's going to be 2 big stages to this project. The first stage is to create the software in Unity to simulate the morphology and their topologies. I believe Andrew already has a Unity environment set up, and it's super interesting. You could actually see the little creatures swimming in the liquid environment, but you will be working a little bit more on that environment first. So that's the first stage. And the second stage is to combine the evolutionary algorithm, which was already included in the 1994 paper, with modern reinforcement learning. And that algorithm is mainly to evolve the topology and also the brain function of the little creature to see how it could interact with the environment and see how it could kind of manage its muscles to swim in the environment. So we'll see how it goes if we combine it with reinforcement learning, and perhaps there's going to be a much better result. So during the process, you'll also be optimizing the swimming fitness function, which is stated in the original paper. And you can actually click on this link, I believe. So it's going to be the original paper, and make sure to give it a scan. And basically, the entire process is an iterative environment design process with the potential to explore a variety of tasks to produce remarkably inventive designs. So this team is looking for 4 to 5 developers with experiences of C#, Python, or C. Experiences with reinforcement learning, Unity, or evolutionary algorithm would definitely be a bonus since it is specific to this particular project. But yeah, that's pretty much it for virtual creatures. The other project would be trying to work on the famous game OSU by creating the beat maps using the recently really famous sequence-to-sequence models. This is a project directed by Jonah, and again, unfortunately, he is not here today. So hopefully I could do a good job in sharing his project ideas and make it appealing to you guys. But basically, let me give you a small background info of OSU. It is a really famous rhythm game where players are presented with a music accompanied with a dedicated beat map. And the players would then use their mouse or pen to follow the patterns on the screen, which also greatly depends on the musical beat itself. And there's a great amount of variety when it comes to the beat map features. As you can see in the image on the left, there's the hit circles, there's the sliders, spinners, and a lot more other really complicated features. So essentially, your task is to design a model that could consistently generate the high quality beat maps. And since all the beat maps are created by the community itself and also reviewed by the community on the platform, the ultimate goal is to generate a beat map and have it ranked on the OSU website, which is actually a really difficult task even for humans. So if you are actually able to create a model that generates a ranked beat map, that would be an amazing thing to accomplish. And we're confident that this is possible because recent successes in transformers for multi-track music transcription is quite promising. And also the set of OSU beat is very large and labeled, which is great for transfer learning and which is also a really important part of the recent success in transformers. And just like think about DeepMind beating Go, OpenAI beating Dota 2. Perhaps this project will be the time for UTMIST to be the famous game OSU. So this team is looking for developers with several responsibilities. There's 3 stages to this. The first stage is that you will be responsible for devising a tokenization scheme and loss function for the OSU automata. Tokenization scheme is basically trying to make the OSU beat map readable by the ML models. The second stage will be to train a existing sequence-to-sequence music model on your own curated data set. And then if it performs well, you will do hyperparameter tuning to try to fine-tune the performance. If it doesn't work out, then you may have to be responsible for coming out with a completely novel architecture. And finally, it is to develop a rule-based post-processing scheme to ensure that we meet the ranking criteria. The reason behind this is the ranking process takes a relatively long time, perhaps on the intervals of months. So it is good to have our own quantitative metric that measures what is a good beat map that is generated by the model. Several requirements for the developers of this project. We do expect Python and proficiency in machine learning libraries like PyTorch, TensorFlow, and JAX. Since most of the sequence-to-sequence models we're using are actually written in JAX, so it is a good bonus if you have experience working with that framework. And of course, we also expect you to have deep learning foundations. It will be great if you have experience with sequence-to-sequence models, using processing, or even some graphics design for the beat map generation. But yeah, those 4 projects are the new ones this year, initiated by UTMIST project directors. And the following 3 projects will be continuations of projects carried on from previous year that are really mature and has a great architecture. So let's start off by having Lisa and Fernando for the second version of Wall Street Bots.
Hi, everyone. Can you hear me? Okay. So Wall Street Bots Crypto is a continuation of last year's Wall Street Bots project. Last year, we built a platform that monitors and deploys machine learning models for stock trading by predicting stock prices with Reddit sentiments. And this year, we're shifting our focus to predict crypto prices instead. The volatile nature of cryptocurrency prices and it's being driven by supply and demand makes machine learning an appropriate tool to predict these prices. And there's 2 parts. There are 2 parts to the project. And Fernando who's the co-director of this project, can talk about the first part, which is the NLP part.
So hey there, everyone. My name is Fernando. Really nice to meet you all. So the first part is building NLP indicators based on data extracted from social media and other sources, including, for instance, Twitter. And the idea is basically to expand the analysis that was done last year on the Wall Street Bots project. So last year I was not in the project, but the project directors that year, they look at sentiment analysis in kind of like a raw form. And this year, what we want to do is take a little bit more attention on the agents that are generating the textual data that we'll analyze. So we'll take a look at who are these people, how many followers they have, like how many people will read their textual data, and how this has a higher or lower impact in the market.
And the second part of the project is creating market predictors based on the market data. So like price, volume, book data of the cryptocurrencies to essentially act like trading signals. This will require a little bit of trading intuition and knowledge of the market. But it's completely fine if you're just interested, and there are people on the team that have previous knowledge and experience working in trading fields, so we are happy to get everyone on board. And then we'll also combine these market predictors with the NLP predictors that Fernando talked about to use as inputs to our final machine learning model to predict the next minute cryptocurrency price. And the final model, back to the previous slide, just one more thing I want to note. So the final model will be deployed on the Wall Street Bots trading platform from last year as a trading strategy. And also this project will likely receive additional high quality data and mentorship guidance from a leading quant finance research firm called G Research. Okay, and then next slide would talk a little bit more about the recruitment. So Fernando, you can talk about the required. Yeah.
Okay, I'll start with the requirements, then later we'll get back to the teams. So we're looking for a large amount of developers, especially because we have like two different foci of the project. So 6 to 8 developers maybe. We would like them to be proficient in Python because most of the project is built in Python, and basically in basic machine learning frameworks and libraries, ASCII-Learn, Scikit-Learn, and like for instance PyTorch. And we'll also preferably be looking for developers that have an interest in trading. That would be great, and the time commitment would be around 1 to 3 hours per week.
And the breakdown of the team structure will be consisted of 3 teams. And note that you're welcome to join more than one team, and all the teams will be working very, very closely together. They just have different focuses. So the first team is the market predictor feature engineering team, and they'll be focused on finding intuitive predictors based on market data to use as inputs to the final prediction model. The second team, the natural language processing team, will be designing clean NLP sentiment indicators to use as inputs to the final prediction model. And the final team, the model prediction team, is mainly in charge of selecting and fine-tuning specific deep learning models to predict the crypto price based on the previous 2 features that we talked about. So that concludes introduction to our project. We look forward to you joining our team.
Thank you, Lisa and Fernando. Another project is called Real-Time 2. It is a continuation of the Real-Time project in previous years that has been working on real estate price prediction. And Sapir is the director. Sapir, would you like to talk more about it?
Yeah, so hi everyone. I'm Sapir and I'll be the project director for Real-Time this year. Next slide, please. Yeah, so just to give a quick introduction, the goal of Real-Time is essentially data-driven, accurate, and up-to-date house price prediction. In order to achieve this, we'll need up-to-date home data extraction. We'll need to augment this data with more detailed and amenity information. And essentially, we're looking to achieve a MAPE of 7.5%. And for those who don't know, MAPE is mean absolute percentage error, and that's our main metric for performance right now. Just to give some quick background on how we started, This is actually the third iteration of the project. This is a project ARSH began 3 years ago. It was called Real Value at the time. And in Real Value, we manually constructed our database with around 500 homes, and it was very limited. And we achieved the MAPE of 15%. Last year, we changed the project from Real Value to Real Time, and we strongly built upon the performance. And this was mainly due to our improvements to our database. So we went from 500 homes to over 36,000 homes, and our whole database workflow was automated. So every 12 hours, we would use Docker files and GitHub Actions to extract homes from our APIs, augment this data, and store it in our MongoDB database. So we worked a lot with CNNs, extra tree regressors, MLPs, and SVMs. But extra tree regressors was our main model, and that was the one that gave us the best performance. And we achieved a MAPE of around 9%. And that's the link to our website for anyone who's interested. Next slide, please. So this is our project summary. There's 4 main tasks we want to work on this year. So the first is to expand our database and update pre-processing methods. So what that means is we want to add several attributes to our 36K homes. For example, amenity information, image data for all these homes. And we want to update our pre-processing methods for these as well. Secondly, we want to explore into other APIs to incorporate into our database. So currently we're working mainly with the Realtor API and the Overpass API. But if we can find any other APIs to kind of add more attributes to our homes, for example, any pertaining to demographic information, which would give some information on like population, crime rate in the area of a certain home, we believe that would have a strong impact on our performance. Thirdly, we'd like to experiment with new architectures. Since our data is going to be changing, it'll be important to kind of do this type of experimentation to try and find the best performing architectures. And finally, the fourth task is going to be a compilation of our results. And if we hit our target of 7.5% MAPE, that'll kind of bring us on par with many companies in the industry and recent research papers. So we can kind of take it to the next level and do some potential industry outreach. For recruitment, there's currently 4 of us, and these are all members continuing from last year. So we're looking to add 2 to 3 more developers to the team. And for these developers, we'd like to see some experience with Python and an understanding of machine learning concepts, as well as some experience specifically pertaining to supervised learning. And yeah, that's it. I hope you guys apply and are interested in our project. Thank you.
Thank you, Safir. The final project that has been carried on from previous year is the 12-led ECG reconstruction project led by Yan. Unfortunately, she is also not here in this meeting, so I'll do the sharing for her. But basically, ECGs are in full called electrocardiograms. They are an essential first-line tool in the diagnosis of many different types of heart conditions. But a complete set of ECG signals, which consists of 12 LEDs, makes it really time-consuming and also quite difficult, because there's studies saying that only 10% of participants, which includes professional participants like doctors, nurses, or technicians, only 10% of them correctly apply all the measuring electrodes. And misplaced electrodes could significantly affect the quality of signals and increase the chance of just having misdiagnosis. So this is why this project wants to work on trying to seek for a technical solution that could reduce the time and complexity of ECG collection and the risk of misdiagnosis. So in this project, we will be investigating various machine learning strategies proposed by groups of biomedical researchers, which are used to reconstruct 12 LEDs ECG signals, given only 2 to 3 LEDs of signals as input. Developers will go through a complete research process, including comprehending academic papers, developing machine learning models, preprocessing and training data, comparing with other models, and making improvements on the current machine learning framework. So basically, you'll first reproduce existing models and then try to develop new architectures that could achieve much better performances. So we are looking for people with experiences in using tools like PyTorch, TensorFlow, Pandas, NumPy, but essentially anyone that's enthusiastic about machine learning are welcome to join. And also one thing to note is this project will be collaborating with On-Hand AI for testing your models on a private data set that is much more accurate and much more relevant to the industry standards. But yeah, this project is looking for 1 to 2 developers, and I bet Jan is looking greatly forward to seeing you guys join the project. And actually, before I move on, let me refresh this page. There are some updates to the PowerPoint. Okay. All right. And now let's move on to the projects where we will be officially collaborating with startups. And the first one is to collaborate with Omni Labs. And this will be led by Brian and Matthew, which are the directors for this project.
All right, hi, so I'm Matthew and I'm one of the project directors for Omni. And we have a quick demo video of Omni Labs in the next slide just to show you what they're working on and what they're building. Oh, the sound is off.
Oh, wait, Stephen, I think you have to reshare with share it with sound.
Okay. 1 second. Maybe this will work.
In the digital economy, writing is the most valuable skill. Blog posts, Twitter threads, or YouTube scripts, all writing. But writing engaging content consistently is hard. So what's the secret? Good artists copy. Great artists steal. The best writers in the world keep track of every noteworthy idea they consume. When they later sit down to write about some topic, they don't just pull up Google and start searching. They find the existing ideas they wrote down and combine them in new ways to create seemingly new content. But that process takes way too much time. Meet Omni, the world's most powerful knowledge retrieval system. Omni captures every idea you've ever written or read and automatically retrieves the most relevant ideas as you write in real time. What files can you sync to Omni? Oh, anything. You can upload entire Google Drive folders or websites. Then, just start typing anywhere in your browser and watch as the most relevant lines from the most relevant files automatically show up in the Omni sidebar. Whoa. Planning a blog or YouTube video about top 10 finance tips? Omni instantly recommends the most relevant passages from your favorite finance books. Scripting a video for your company's new service? Every ad copy your team ever wrote instantly appears before your eyes. Writing hiring guidelines for an engineering position, but you missed the last Zoom meeting about this? Automatically pull insights from the meeting transcription without opening a single new tab or folder. Whether you're a researcher or a student, finding your sources and citations becomes as easy as selecting text. It's like having a second brain that instantly surfaces the knowledge that you forgot was even there at exactly the moment you need it. Or better yet, when you didn't even know you needed it. With Omni, you'll never have to worry about managing or trying to find your knowledge ever again. All right, thank you for that quick little demo. So for a bit more context, this project is in collaboration with an early stage startup founded by 2 ex-Google software engineers based in San Francisco. And the goal of our project specifically is to extend the existing capabilities of the Omni Chrome extension, which is still in beta. And as you've seen in the video, the current extension retrieves knowledge from a user's existing database based on what you type or highlight in your browser, and it ranks the results based on semantic similarity. And so the scope of this project is to implement the ability to not just use semantic similarity, but include other heuristics as well, such as finding contradictions of a claim, questioning the assumptions behind a claim, and so forth. So for example, if a user highlights
a comment saying the earth is flat on YouTube, they can select to see examples of passages from their database of knowledge that either refutes that claim, finds a good example of that claim, or questions the assumptions behind that claim, and so on. And this set of features would supercharge a user's ability to think critically about any given topic as they read or write about it in real time, as they'll have instant access to examples of various models of thought. So next slide. For recruitment, we're looking for a team of about 6 developers with a strong demonstrated experience in software engineering in large teams and following best practices. So we're hoping to implement a web app first, independent of the Omni Labs code base. And if the implementation goes well, we'll integrate with their Chrome extension, where our work will be pushed to production and be used by people in the real world. And so we're looking for people to develop both the front end, back end, and natural language components of this web app. We're looking for people with demonstrated prior ML experience using industry standard libraries, proficiency in Python, and preferably experience in natural language processing. And we're also looking for people with a strong ability to self-regulate and take initiative, as we'll be contributing to a real-world product. And the time commitment on this project will be roughly 4 hours a week. So if you're interested, please contact me, Matthew, or my teammate, Brian, on the UTMIST Discord or through the email addresses listed on screen. And so I'll just give you some time to note that down or take a screenshot or something. But yeah, that's everything I have for you, and I'm excited to work with whoever's excited to apply.
Thank you, Matthew. All right, the second collab project will be with AltaML. And basically, you will be creating a pipeline for the construction industry. The directors and the developers that we're recruiting will be closely working with Doije from AltaML, and UTMIST will also be leading throughout the process. Basically, the construction industry has these kind of files called RFI files, and for every single project in the construction industry, they have to manually process thousands of these files, and it takes a lot of time and human labor. So basically, this project is trying to build an automation pipeline to process these files. So it's mainly an NLP task with a lot of software engineering included. But a lot of details, we are still in the discussion with AltaML and Doije. So stay tuned for that. We are expecting to upload the proposal for this project by the end of next week. So what we would like you guys to do is to, if you're interested in this project, we recommend you to apply for the other positions first, including the UTMIST projects or the other collabs projects if at your own will. And by the time we upload the proposal by the end of next week, you can submit a separate application for this project. The requirements for this are really similar to the descriptions written in the previous slides. So if you're interested in this project, just check out the previous slides. And just keep in mind, we are recruiting for both directors and developers for this project. And moving on, we have our final collab project with PhotoML. And I think Yusuf is in this meeting to share with us about it.
Yeah, thank you so much, Stephen. Hey, everyone. My name is Yusuf El-Zahiri, and I'm a student in the combined JD MBA program at the Faculty of Law and Rotman School of Management. I'm working on a startup project with my business partner, Chantal Sorhendo, who's adjunct faculty at the University of Toronto and a nurse practitioner at St. Michael's Hospital. Chantal and I want to give, firstly, a massive thank you to the excellent UTMIST leadership team for giving us a couple minutes to share a project with you. Chantal, unfortunately, is unable to join us today, so I'll be leading this presentation for the two of us. We can just jump on to the next slide. We're really excited to share this project with you. It's an opportunity to build a product that assists professional photographers with the culling portion of their work. We're calling this project Choosing the Face, and it's labeled under PhotoML for UTMIST. So to understand what culling is, imagine a photographer goes out and shoots a wedding, taking thousands of pictures. Naturally, they're only going to want to send a sample of those best images to their client. So the way they narrow down their pictures from thousands of images to just 100 or so, industry professionals call that process culling. And we want to work with you to build a machine learning algorithm that automates this process. And what's critical, it has to recognize that each user, meaning professional photographer, completes this culling process in their own unique way. It's essential that our product understands this personalization aspect and can replicate it. So to narrow the scope a little bit, we've created a baseline goal that focuses on achieving this task for pictures that deal with facial images. So we want to do things such as recognize emotions and determine which images are best to keep, to do focus and blurriness assessments, teach the software how to choose the best image among duplicates, and so on, but all in ways that are tailored to the specific user. We see this as a really exciting opportunity for you to work with a startup to build something that you have real control in shaping. So let's go to the next slide. But with that being said, we're looking for two main things which are outlined in our project proposal that I believe can be found through UTMIST. So the first thing that we need is one project director. The director will be working closely with Chantal and myself and really lead the developers team. For this role, we need someone who's coachable, open to new ideas. We need a transformational leader who empowers team members to thrive, has creative vision, possesses strong problem-solving skills, because we know we're going to need those, exhibits humility, and has excellent communication skills. And this individual really needs to know how to lead a team and has strong to exceptional machine learning skills and experience. We expect that the director can contribute a minimum of 4 to 6 hours per week. We're also going to need 4 to 6 developers. These individuals also have to have strong and open communication skills. They have to be self-starters who can quickly identify challenges and potential solutions for those and consistently meet deadlines. And it'd be great if they have previous knowledge in machine learning projects. We expect that developers are able to contribute a minimum of 2 to 4 hours per week. I'll be happy to answer any questions you may have or make any clarifying points during the Q&A period. But I just want to say that we're really looking forward to working with you and giving you a stimulating opportunity to continue to learn, refine, and apply your technical and research skills and overall knowledge. We want to give you a chance to work with industry professionals and contribute to building something in a very meaningful and involved way. So I put my contact information on the screen as well as Chantal, so feel free to reach out to us with any questions later on if you don't get a chance to ask them now. But thank you so much, everyone. I'll pass it back to Stephen.
Thank you, Yusuf. And that will actually conclude all the projects we have this year. We have 10 projects in total. That is some amazing stuff. And for all the information, detailed proposal and stuff, it will be uploaded to our website by tonight. So if you're ever interested in any specific project, just stay tuned with our website update by tonight. And with that, I guess we could hop into the Q&A sessions if any one of you have, whether it is a general question or a directed questions to specific directors and projects. You could either just voice it out, raise your hand, or type in the chat. Will most positions be remote? Yes, likely, but it also greatly depends on the directors themselves. But we will not require in-person meetings in any way unless it's efficient. So it greatly depends on the directors themselves. Application deadline will be the 20th of September for the Google form. After that, you will go through an interview process and onboarding by the end of September. Oh yeah, I know. Ariel, Jack, Marsh, if you guys want to answer any questions, just feel free to jump in.
Oh yeah, of course, I can try my best to answer the chat questions. Do you want to just like take?
Oh yeah, sure. You can do chat. I'll do the audios then. All right, let's do Lance first. Do you have a question?
Hi, yeah. I'm sorry if I missed it, but I wanted to know how many developers Numer AI is looking for.
So our project, as we said, is very horizontally scalable. So it depends on how many applications come in and how many. It also depends on the capability of our mapping model. So that we're very flexible. We want to see how many applications that we get and what are the level of talents that each of the applicants have, and we'll decide after that. So as I said, it's very flexible. We could potentially have a very huge team.
Okay, thank you very much.
No worries.
Thank you, Lance. Before we move on the audios, I'll have there. Oh my God, there are a lot of questions in the chat, but just to answer a few.
I can try to answer the question in the chat, and then like you can moderate the. I'll just type in the answer in the chat. I'm saying, you can answer like people who raise hand. Yeah.
All right. Joaquin, I'm sorry if I didn't pronounce your name correctly. But
I'm actually very impressed. You pronounced it correctly. Thank you. I was just wondering, because you said that you can apply for multiple positions, but is there like a limit or like a guided practice that you should do? Because there's a lot that I'm interested in, but I don't know if there's, yeah.
All right. So we do recommend only applying to either developer/directors or the front end and product associates. So it's going to be a lot of workload if you apply for multiple of these big roles. So that's the first point. Second point is, in the Google form, you will be able to state your preferences for each of the projects. So if you were to apply as a developer, you can tell us your top 3 favorite projects. You will be asked for a short prompt to why you want to join, or some relevant experiences regarding those projects. And at the bottom of the Google form, you will see a prompt that asks you if you want to become a director or a developer for the collab projects.
If I may ask another question, just to clarify. So on the actual application, it's not like an application for one of the teams. It's like an application for all the teams.
Correct.
Okay, thank you so much.
Lance, do you have another question?
I don't, sorry.
No worries.
I can answer the question by Asad in the chat. So the interview for project developer, they'll all be project specific. You're gonna be interviewed by the project director of that project. But for interview for the front-end developer and also the product associate, it will not be project specific. They will be interviewed by VP engineering and also VP academic, and probably also by me. Yeah. So, hope that answered your question.
Okay, go ahead.
I just had another question. It was mentioned on the New Mirai project that like beginners or people that are new to ML is like not like recommended, but because of the horizontal scaling, it's like good. Are the collabs then going to be restricted to only those that have prior experience, as they are, industry based?
Oh, no. On the contrary, like beginners are very much welcome, because you could build a not so good model, but it's going to contribute to your meta model anyways. That's the spirit of open source AI, right? So as long as you're willing to learn, you're willing to dedicate your time to perfect your model, you're welcome on our team. So yeah.
And for the collab projects,
thank you.
For the collab projects, it will have a much higher requirement than for qualifications, because the main thing about the collab projects is it's either going to be a much tougher software engineering task, or it's just going to be, there's going to be a great degree of liberty for both the directors and the developers. So you have to be pretty familiar with at least the PyTorch, machine learning frameworks, and perhaps even working on a product. So that way we could actually produce something within the 6-month development cycle. But do just feel free to apply for any one of them, because it never hurts, right? So just to let you know.
Okay, thank you so much.
Yeah, if anyone else has questions, feel free to ask. We're here to answer all your questions. And that's the purpose of this info session. Yeah.
I guess, Jack, we could stay behind for until like 12:35 or 12:40, and then if there's any questions, we'll just answer it there. If not, then feel free to leave. And if you have any follow-up questions, just ping us on Discord, and we'll definitely answer you as soon as possible.
Yeah.
Thanks everyone for attending the session. I really appreciate it that you gave your time.
Hey, can I ask a question before I go?
Oh yeah, sure. Go ahead.
Yeah, so I have really limited MI experience, or not MI, like machine learning experience. What are my like chances of getting into one of these, like applying as a developer for one of these projects?
You have a high chance, I'll say, yeah, because like I started as a person without much knowledge in my first year, and actually I was in a project led by Matthew and Brian, like the one that does like Omni AI this year, and they accepted me, and I end up learning a lot of stuff. So so to give it a shot, you have a high chance to be accepted, and there are also project response for level of difficulty, and there will be one for you for sure. Yeah.
Okay,
Hope that
thanks.
answers your question. Yeah.
Yeah. Okay. Thanks. Yeah. Perfect. Thank you.